Quick note, this is an AI-assisted recap made for learning, not the original video, and not an official translation. AI engineering is the skill of turning foundation models, the large language models behind ChatGPT, Claude, and Gemini, into products that are useful, safe, fast, and reliable. Those 4 qualities are the compass the whole book keeps coming back to. This recap distills Chip Huyen's book across 4 moves: the big picture, foundation models, evaluation, and how you actually improve quality. A demo is 1 prompt, 1 model call, manually tested, low stakes, no monitoring. It looks impressive on your laptop. Production is a different animal: system design, evaluation pipelines, context and tools, model routing, guardrails, monitoring, and a feedback loop. 3 forces made this a discipline: stronger models that reason and code, easy access through APIs and tools, and a far lower time to build. You can stand up an app in minutes with tools like Replit or Lovable. It starts with a use case, the problem worth solving, then choosing a model, then defining how you will measure success. Only then do prompts, retrieval, agents, or fine-tuning come in. This is the stuff most people jump straight into, but they are levers to raise quality, not the starting point. Production makes it reliable at scale, monitoring tracks failures, cost, and latency, and the feedback loop keeps it improving as models change. A foundation model is a general-purpose, often multimodal model. It takes in text, images, and audio, and one model can chat, summarize, reason, and write code, adapted to almost any task. It reads text as tokens, words or fragments of words, and learns by predicting the next token from massive unlabeled data. That is the key mental model. It is a prediction machine, choosing the next token by probability. It is not deterministic. Because tokens are sampled, the same prompt can give different valid answers. Temperature, top P, and top K all dial how random that sampling is. Hallucination is when the model makes something up and sounds confident. It will happily invent a citation or an event that never happened. It comes from knowledge gaps, pattern completion, and weak grounding. The most likely next token is not always the true one. Better context, evaluation, and guardrails are what pull hallucination down. Evaluation turns AI development from guesswork into engineering. Without it, you are just hoping the outputs are good. It is hard because outputs are open-ended and subjective. Exact evaluation checks verifiable things. Subjective quality needs humans or an LLM as a judge. Public leaderboards rarely match your data or domain. Define success, build a private evaluation set, run side-by-side benchmarks, and weigh quality, safety, cost, and latency together. Prompt engineering is the fastest way to change behavior without changing the model. It is cheap, flexible, and the best first step. A strong prompt combines 5 parts: a role, a clear task, useful context, a few examples, and a target output format. For instance, act as an expert assistant, summarize these notes, and return 3 bullets and 1 action item. Start with prompts, and version them so you can compare and roll back. Only then move on to retrieval, agents, or fine-tuning. Prompt injection is untrusted input trying to override your system, ignore previous instructions, reveal the hidden prompt, or trigger unsafe tools. It sneaks in through user input, files, web pages, and retrieved documents, so treat all retrieved content as untrusted. Keep a clear instruction hierarchy, restrict tools with allow lists, rate limits, approvals, and audit logs, and check both inputs and outputs before they reach the user. Retrieval augmented generation gives the model facts it did not memorize. You chunk documents, embed them, and store them in a vector database. At query time, you pull the most relevant chunks and add them to the prompt as context, so the answer is grounded. Keyword search nails exact terms, semantic search understands meaning, and a hybrid of both usually wins. Most gains come from better retrieval, clean documents, strong chunks, re-ranking, and reliable indexing. An agent extends RAG. Given a goal, it plans, calls tools, observes results, updates memory, and iterates until the task is done. Tools make agents powerful, but grant least privilege, only the access they truly need. Don't hand one agent 25 tools, or the memory blows up and results get weak. Keep memory fresh so cost and context stay under control. So the whole ladder is, start with prompts, add RAG, reach for agents last. The full walkthrough is linked below. Enjoy building.